All right, today we're going on a bit of a safari. But forget lions and tigers, we are hunting for something way more elusive. A species that's literally all around us, shaping our digital world every single second. Yep, we're talking about machine learning. Think of this as your field guide for spotting it in the wild. Okay, so let's start with a puzzle. Brain scans, spam filters, video games. At first glance, these things have absolutely nothing to do with each other, right? I mean, one is life-saving medical technology, another is just a daily convenience, and the last one is pure entertainment. But they all share this powerful and visible engine. And once you know what to look for, you'll start seeing it everywhere. So our first sighting is in a hospital. An ML algorithm looks at a super complex brain scan, and it can outline a tumor with a level of precision that's just incredibly difficult for the human eye to match. This is a huge deal, helping doctors make critical diagnoses way faster and more accurately. Now, let's look at a much more common species, one we all run into every single day. You know that spam filter that protects your inbox? That is machine learning in its natural habitat. It's constantly learning, constantly evolving to figure out what's a real message and what's just digital junk.
And you've definitely spotted this one. Every time a streaming service suggests a new show or an e-commerce site says, hey, you might also like this, you've found it again. It's analyzing patterns in what you do to predict, with kind of scary accuracy, what you're going to want next.
And in the world of gaming, ML is creating opponents that actually learn from your moves. We're not talking about some pre-programmed, predictable pattern here. This is a system that learns to play by trial and error, and it gets better and better with every single game it plays against you. So we've seen it everywhere, from our hospitals to our hobbies. The big takeaway here is that these systems aren't just following a static set of rules. They are genuinely learning. But how? How does a machine learn? That's the real mystery we're here to solve today. You know, it really boils down to two main approaches. Just think of it like this. Some machines learn with a teacher, someone giving them constant feedback, all the answers right up front. We call that supervised learning. And then there are others that are basically thrown into the deep end and told, hey, figure it out for yourself. That's unsupervised learning. Let's dig into that first one, which is actually the most common method you'll find out there, supervised learning. The whole idea here is learning from examples that are already solved. The secret ingredient for this method is something called labels. Now, a label is just the correct answer that we humans give to the machine beforehand. The machine gets a massive data set where every single piece of data already has the right answer attached to it.
Let's go back to our trusty spam filter. So in step 1, you just feed it a mountain of emails. But here's the crucial part. In step 2, a human has already gone through and labeled every single one. This is spam, this is not spam. The machine's job is to then work backwards and figure out the hidden patterns that separate the good emails from the bad ones.
And this is the perfect way to think about it. It's exactly like learning with an answer key. For every email it looks at, the algorithm makes a guess. Then it checks its guess against the answer key, that label, and it tweaks its own internal logic. It does this millions of times until it gets incredibly good at telling the difference all on its own. This whole learning with an answer key thing is incredibly powerful. It's used for what we call classification tasks, like our spam filter, but also for something called regression. That's just when you're trying to predict a number, like forecasting a company's revenue or the price of a house. The fancy engines that do this work have names like linear regression or neural networks, but the core idea is always the same: predict an outcome based on a ton of labeled examples. All right, let's jump over to the other side of the digital jungle. What happens when there's no teacher, no answer key? Well, welcome to unsupervised learning, where the machine basically becomes a detective. So here, the data is a complete mess. It's totally unlabeled. The algorithm gets a giant pile of raw information, and its only instruction is, go explore this and see if you can find any kind of structure, any hidden patterns, or natural groups, all by yourself.
Just look at this data. This is what an unsupervised algorithm sees. It's a jumble of info about visitors to a blog, their gender, their interests, when they visit. There are no labels, no predefined groups, no right answers. It's just data.
So, put on your detective hat for a second. Looking at this mess of data, can you start to see any connections? Any visitors that kind of seem similar to each other? It's pretty tough, right? But this is exactly what the machine is built to do. And this is what it might find. With absolutely no help from us, the algorithm could discover these natural clusters in the data. It might notice a strong connection between visitors who are male, love comics, and tend to show up in the evening. And it might find a totally separate group of sci-fi fans who mostly visit on the weekends. This amazing technique is called clustering. And this ability to find hidden structure is used for all sorts of incredible things. Companies use clustering for customer segmentation to really understand their audience. Banks use something called anomaly detection to spot fraudulent credit card transactions that just look different from everything else. It's all about finding the odd one out, or the hidden group. Okay, so we've got learning with a teacher and learning on its own, supervised and unsupervised. For our field guide, why is this distinction so important to understand? Why does it matter? Well, it matters because it gets to the very heart of how an AI system actually works. If you know whether a system learned with labels or without them, you understand the kind of problem it was built to solve. Is it designed to classify things into categories we already know, or is it designed to discover brand new ones we've never seen before? So next time you interact with an AI, just ask yourself, was it taught with an answer key, or did it have to figure things out on its own? The answer tells you everything about what it can and can't do. So here's the bottom line. You now have the field guide. You can spot these systems out in the wild, and you know the two fundamental ways that they think. Which leaves us with one last big question to chew on. The systems that learn from what we already know, or the systems that find patterns we never even knew existed? Which one of those do you think is going to change our world the most?